Theory of evolution speaks in every population there is a variation. When conditions change, those by student and environment will survive and reproduce carrying on this characteristic to their offspring. Over time, this characteristic will become more common in the population. Eventually, the new addition is passed respectful to the species becomes so different that they could be regarded as separate species. But have you ever wondered who came up with this theory and their evidence for it? The mob came to the conclusion that living things evolve by the inheritance of acquired characteristics. In the perspective of the giraffe, the cried they acquired their long necks from their short neck ancestors. He believes that in constantly striving to reach as least high in the trees which were out of reach smaller animals, they stripped the necks. This characteristics was then inherited by their young. The mark included that. This sequence repeated over many generations resulted in the long necks of the modern giraffe. However, his theory was disproven. First, it was assumed that the body of an organism could change shape and form some parts, such as an egg, but under strain or is required for more constant use than other parts. This is true as if you were to train the wheat. If you are a long period of time, you will develop muscles. However, this doesn't necessarily mean that you would carry this characteristic to your offspring, which works his second assumption. For example, if a skinny man was to develop a muscular body, this would not necessarily mean that they would have bigger children. Is therefore his theory instead returned to the Yan theory of evolution. Darwin's theory of evolution is the one that we use today. Darwin's evolve your ass as well. Specifically, he believes that in giraffe population there is a variation, most likely the neck being distinctly longer than the others as the environmental condition. So it changes in the individual with the longer neck survive and reproduce, passing this characteristic of a longer neck that offspring. Those were the shorter necks most likely died beautiful due to the condition over many generations. The long necks for us is it a more common for me the species that we know today.
Hycoichthys 530 Maya, also known as hycofish. It is a genus of craniate that originated during the Cambrian period in what is now Asia. Notable for being the very first fish, it is also the oldest and most primitive known backbone animal on Earth, being the forefather of fish, amphibians, reptiles, mammals, and humans. Cephalaspis, also known as headshell, a genus of armored fish in the early Devonian about 400 million years ago. It was one of the jawless fishes, or ostracoderms, which were common at the time. Eustenopteron, 385 million years ago, is a genus of prehistoric lobe finfish which has attained an iconic status from its close relationships to tetrapods. Early depictions of Eustenopteron show it emerging on the land. However, paleontologists now widely agree that it was a pelagic animal. Tiktaalik 375 million years ago is a monospecific genus of extinct Cercopterygian from the late Devonian period, about 375 Maya, having many features taking the those of tetrapods. Hynerpiton 360 million years ago is a strange amphibian from the Devonian. It lived about 360 Maya and was 5 feet long. Hynerpiton is featured in the first episode of the 2005 documentary series Walking with Monsters. It was seen fancifully and erroneously evolving from Cephalaspis and then on land. Dimetrodon 300 million years ago is an extinct genus of non-mammalian synapsid that lived during the Caesarean and early Permian. Around 295 to 272 million years ago, it is a member of the family Sphenacodon today. Gorgonops, literally gorgon face. It is an extinct genus of therapsid which lived about 255 to 250 million years ago, during the latest part of the Permian period. Lystrusaurus, also known as chubby lizard, is an extinct genus of Dicynodont therapsid that lived during the late Permian and early Triassic periods. Trinoxodon, 245 million years ago, is an extinct genus of cynodonts, most commonly regarded by its species Palearhinus, which lived in what are now South Africa and Antarctica during the early Triassic. Megazostrodon, 200 million years ago, is an extinct mammalia form that is widely accepted as being one of the first mammals, and which appeared in the fossil. Glaciodapis, also known as Nearadapis, in 60 million years ago. It is a type of specimen named after the three cusps present on its upper incisors. Egyptopithecus, 34 million years ago, is an early fossil catarrhine that predates the divergence between hominids, or apes, and cercopithecids, or old-world monkeys. It is known from a single species, Egyptopithecus zoxys, which lived around 38 to 29.5 million years ago in the early part of the Oligocene epoch. Brachiosaur, 20 million years ago, is an extinct genus of primates that existed from 21 to 14 million years ago during the Miocene epoch. Fossil remains are present in Eastern Africa including Kenya and Uganda. Australopithecus, 4 million years ago, a group of extinct primates closely related to, if not actually ancestors of modern human beings, and known from a series of fossils found at numerous sites in Eastern, North Central, and Southern Africa. Homo erectus, also known as upright man, in 1.5 million years ago is an otherwise extinct species of archaic human from the Pleistocene. With its earliest occurrence about 2 million years ago, Homo erectus had a human-like gait and body proportions, and was the first human species to have exhibited a flat face and have prominent nose and possibly sparse body hair coverage. True brain size certainly exceeds that of ancestor species. Capacity varied widely depending on the population.
Homo sapiens. The name Homo sapiens was applied in 1758 by the father of modern biological classification. It had long been known that human beings physically resemble the primates more closely than any other known living organisms. But at the time, it was a daring act to classify human beings within the same framework used for the rest of nature. Linnaeus, concerned exclusively with similarities in bodily structure, faced only the problem of distinguishing Homo sapiens from apes, like gorillas, chimpanzees, orangutans, and gibbons, which differ from humans in numerous bodily as well as cognitive features. Charles Darwin's treatise on evolution and the origin of species would came 101 years later.
Theories of evolution of life timeline. Aristotle, 384 to 322 BCE. Greek philosopher classified organism in scala naturae, where organisms are ranked according to their ability to move and see. Carolus Linnaeus, 1707-1778. Swedish naturalists laid down the binomial system of nomenclature, classified living things in Systema Naturae in 1745. George Cuvier, 1769 to 1832, French naturalists and geologists proposed the theory of catastrophism in 1796, states that there have been catastrophes that contributed to the rapid changes in species. James Hutton, 1726-1797, Scottish geologist, physician, and naturalist, proposed the theory of gradualism in 1795. His theory states that the profound changes is the cumulative product of slow but continuous processes. Charles Lyell, 1797-1875, British lawyer and geologist, proposed the theory of uniformitarianism in 1830. Theory of uniformitarianism. This theory states that mechanisms of change are consist over time. French naturalist Jean-Baptiste Lamarck, 1744-1829, published Philosophy Geologique in 1809 and described the concept of use and disuse. Use and disuse. This concept states that traits that were used were passed down to other generations, while traits that were not adapted to the environment were disused. Charles Darwin, 1809 to 1882, English naturalist and geologist, contributed 5 theories about the evolution of life. Darwin theories about the evolution of life. Evolution. Species come and go through time. While they exist, they change. Common descent. Organisms are descended from one or several common ancestors and have diversified from this original stock. Species multiply. The diversification of life involves population of one species diverging until they become. Gradualism. Evolutionary change occurs through incremental small changes with population. New species are not created suddenly. Continuation of Darwin's theory about the evolution of life. Natural selection. Evolutionary change occurs through variation between individuals. Some variants give the individual an extra survival probability. These people have contributed much to the world. They have helped us understand how life goes on in.
Darwin and Revolution. Darwin had always wanted to study nature, even though his father wanted him to be a doctor or a priest. Defying him young, Darwin embarked on a ship sent to the chart and coast of South America because he wanted to connect and study exotic animal specimens. What he found on the 5-year trip would lead him to the question his beliefs. What if species weren't as permanent and perfect as everyone thought? In Argentina, Darwin found fossils of what looked like giant armadillos and sloths. Clearly, these animals had existed at some point, but they didn't anymore. This made Darwin suspect species had changed over time in line with some existing but unpopular theories. He had also seen mockingbirds, and when he got to the Galapagos, he found different mockingbird species on the island distinct among each other and from the mainland species. Because of their sheer similarity and closeness, Darwin hypothesized that they had a common ancestor whose specimens and had flown to the island and changed there. However, something was missing. How did this change happen? Darwin's inspiration came from economists Thomas Malthus, who believed that humans reproduce faster than their food supply. Darwin realized that animals always breed beyond their available resources, so the individuals who were better at surviving would be the ones to reproduce this way. They would pass on any traits that had helped them to survive. Everything fit together, but there was a final hurdle. Darwin, like the society he lived in, was deeply religious, and all the evidence had found contradicted Christian beliefs. It would take him over 20 years to write and publish his revolutionary book on the origin of species, but when he finally did, it became one of the most influential scientific treatises at all time.